electron. E by m is the specific charge of the electron, where E is the charge of the electron, m is the mass of the electron. So E by m is called the specific charge, or it's for so the determination of specific charge was conducted by the Thomson. So already I told you that 1887 Thomson conducted the experiment. So he started the first experiment to open the new branch of physics, modern physics. That physics is called the modern physics. So using that, he started to study the structure of the atom. So he is the proponent of the modern physics. So here, the J.J. Thomson method, that experiment setup is on display on your screen. See that. பார்த்தீங்க அப்படின்னா that J.J. Thomson, that experiment setup எல்லாருமே பார்த்துருப்பீங்க. இது எதுவும் தெரியுமா உங்களுக்கு யாருக்காவது? யாராவது கேத்தோட் ரே பார்த்துருக்கீங்களா? Anyone? Students? Hello? தினேஷ்
சார்
கேக்குதா? இதுக்கு முன்னாடி கூலிங் ஸ்டீவ் பார்த்துருக்கீங்களா யாராவது? இதுல யாரா பாத்துருக்கீங்களா? ஆனா எல்லாரும் பாத்துருக்கீங்க. எது தெரியுமா? நீங்க பாக்குறீங்களா டிவி, பிக்சர் டியூப், எல்சிடி டிவி இல்ல, ஆர்டினரி டிவி இருக்குல்ல, பிக்சர் டியூப். இந்த கடை முன்னாடி எல்லாம் பாத்துருப்பீங்களா? போன் மாதிரி வச்சிருப்பாங்களே, முன்னாடி ஸ்கிரீன் இருக்கும், பின்னாடி வந்து ஒரு பிளமன் மாதிரி வச்சிருப்பாங்க, பாத்துருக்கீங்களா?
பாத்திருக்கேன் சார்.
அந்த டிவி ஸ்கிரீன் பாத்தீங்க அப்படின்னா இதுதான் அந்த டிவி ஸ்கிரீன். அந்த மேல வந்து இப்ப நம்ம டிவி கட் ஆனோன்னு சின்ன சின்னதா புள்ளி புள்ளியா தெரியும், பாத்துக்கீங்களா? அந்த டாட்டட் லைன்ஸ் வந்து ப்ரொடியூஸ் ஆகும் ஸ்கிரீன்ல. அதுக்கு பேர் தான் வந்து ஃப்ளோரசன்ஸ். அந்த ஸ்கிரீனுக்கு மேல வந்து ஒரு கெமிக்கல் கோட் பண்ணியிருக்காங்க, அதுக்கு பேர் ஜிங்க் சல்ஃபைடு. அதுல வந்து எலக்ட்ரான் விழுந்த உடனே அதுதான் க்ளோ ஆகும். அப்ப நீங்க எல்லாருமே எலக்ட்ரானை பார்த்துருக்கீங்க, ஓகேவா? நீங்க அந்த டிவியை கழட்டி பாத்தீங்க அப்படின்னா பின்னாடி வந்து ஒரு ஃபிலமெண்ட் மாதிரி இருக்கும். அந்த ஃபிலமெண்ட் மாதிரி இருக்கிறதா பாத்தீங்கன்னா இந்த இடத்துல ஃபிலமெண்ட்டுக்கு இடத்துல இந்த பேட்டரி, இந்த சீல் இருக்குது பாத்தீங்களா, இதுதான் அந்த ஃபிலமெண்ட். அதுக்கு மேல ஒரு கருப்பு கலர் ஒயர் மாதிரி குத்தி வச்சிருப்பாங்க, அதுதான் வந்து ஹை வோல்டேஜ் இது குத்திருப்பாங்க. அந்த இதான் இடம் தான் அந்த ஃபிலமெண்ட்ல இருக்கும். அது போக பாத்தீங்கன்னா இந்த கோன் பார் இருக்கும். ஸோ இதுல வந்து பாத்தீங்கன்னா ஒரு ஷேப் கொடுத்துருக்காங்க, ஒரு பெல் ஷேப்ல. பட் அது நீங்க பாத்தீங்க அப்படின்னா உங்களுக்கு கோன் பார் இருக்கும். இந்த PQ, PO ஆர் P டேஷ்னு ஒரு ஸ்கிரீன் கிரீன் கலர் இருக்கு பாத்தீங்களா, தட் ஃப்ளோரசன்ட் ஸ்கிரீன். இந்த ஃப்ளோரசன்ட் ஸ்கிரீன் அப்படிங்கிறது தான் வந்து உங்களுடைய அந்த டிவி ஸ்கிரீன். ஸோ அதுலதான் வந்து இதை நம்ம யூஸ் பண்ணிருக்கோம், ஓகேவா? சரி. So now
Yes,
we
sir.
can see that lesson. So see here, the battery is connected to the filament. Filament means the tungsten wire is inside the tube. That tube is called, this is made up of glass tube, that glass tube. So battery is connected to that filament. When low tension battery is connected to that filament, when current is flowing through that filament, it produces the electrons or it emits the electrons. So the filament connect பண்ணனும் என்ன ஆகும் அப்படின்னா, electrons are emitted from the filament here. So the emitted electrons are moving in a different direction. So anode is here. So the anode makes the electron to passes through the axis. ஒரு சின்ன ஹோல் பார் இருக்கும், அது வழியா மட்டும் தான் பாஸ் பண்ண allow பண்ணும். So that anode is here. So the anode allows the electron to passes through the axis of that circle, cylindrical shape of that A. Then high voltage battery is connected between that cathode and anode. So we are applying the high potential difference. That high potential difference means that is 10,000 volt. That's 10,000 volt potential difference applied between the anode and the cathode. So after emitting that electron, that high potential difference accelerate the electrons. So electrons are moving from here to here through this way. Here two plates are there. That one plate is positive and another plate is negative. That is charge given to them. That is electric field. So two electrodes are there. One plate is given a positive charge, another one is negative. So electric field is applied here. And see that S and N. N is a north pole, S is a south pole. So magnetic field is applied perpendicular to the electric field. So electric field is acting in a upward and downward direction, from up to downward direction. Then magnetic field is acting from north to south. the two fields are right angles to each other. Then that electron is falls on the screen. Suppose you can consider that point O, the electron is falls on the screen O, it produces the fluorescence on the screen. So you can able to see the electron, right? So this is the experimental setup. So using that, now we are going to calculate that E by M of an electron, that is specific charge of an electron. That first method. Here the green color line, indicates that path is the path of the electron. That electron is moving in a green color line. The two electrons are here. That is electric field applied between the two plates. So it is act from the positive terminal to negative terminal. So electric field is acting in a downward direction. Magnetic field, that is acting between the north to south. So magnetic field B acting perpendicular to the electric field. So the two fields are right angles to each other. See here, another two fields are acting here. One is the gravitational field. So gravitational force is acting on the electron. So it is acting in a downward direction. Another one is electric field acting in a upward direction due to the applied of the electric field. So the two fields, electric field and magnetic field, is acting perpendicular to the two fields. So using that, now we are going to calculate the velocity of the electron. So this is the path of the electron. Now we are going to calculate the velocity of the electron. When the electron is placed in the electric field, it experiences the force. That force F is equal to small e into capital E. So this is a small e into capital E is the force experienced by the electron when it is placed in an electric field. And see here, EBV. That is EBV is the force experienced by the electron when it is placed in the magnetic field. So magnetic field வைக்கும்போது அந்த சார்ஜோட force எவ்வளவு இருக்கும் அப்படின்னா F is equal to BEV. அதே electric field வச்சா F is equal to E into E. So these two forces are equal. So equating these two forces, so what happened? That E cancel each other. Remaining value EBV is that we need that value of V. So V equal to E by V, where V is the velocity of electron. E is the applied electric field. V is the applied magnetic field. If you know the value of electric field and magnetic field, you can calculate the velocity of electron. Right? So this is the first thing. Next one, we are going to define the determination of specific charge. So now we are going to calculate the specific charge, that is E by M value. So after producing that electron, we are applying the 10,000 volt or 10k volt applied between the anode and cathode. Electrons are accelerated. So when electrons are accelerated, definitely it has the kinetic energy. So you know the kinetic energy formula, that is half mv square. So here EV is the stopping potential, that is equal and opposite force. இது நம்ம 7th லெசன்ல படிச்சிருப்போம், ஞாபகம் இருக்குன்னு நினைக்கிறேன் உங்களுக்கு இந்த ஈக்குவேஷன். EV0 applied potential into charge of an electron is equal to the half mv square. V is the applied potential, we are applying the applied potential. E is the charge of an electron, that is equal to half mv square. So applied potential is converted into kinetic energy. So definitely these two things are equal. So EV equal to half mv square. Or you can write that equation E by M. So M is brought here. So E by M equal to V square by 2V. So in 7th lesson, we calculated the value of V. V square equal to this value, or V equal to 2EV by M, root of 2EV by M. The same thing here, it is converted into E by M equal to V square by 2V. And we know the value of V. V equal to E by V. Now only we calculated that velocity of an electron, V equal to E by V. Substituting that value in this equation, so you will get E by M equal to 1 by 2V E square by V square. So here you know the value of electric field E, magnetic field V, and velocity of electron V. So substituting all these values, you will get the specific charge of electron equal to 1.7 into 10 to the power of 11 coulomb per kilogram. So here unit of charge is coulomb. Unit of mass is kilogram. So coulomb per kilogram or coulomb kilogram inverse watt. So it's a unit of specific charge. Right. The two methods are over. Again, we are going to get the same value, but in a different method. So here, the deflection of charge only due to uniform electric field. But I again we are applying the electric field and magnetic field. Two fields are applied. Now, deflection of charge only due to electric field. That means we are not going to apply the magnetic field. So we switched off that magnetic field. Only we are applying the electric field. So this is an electron. A electron is coming from this place. So electron is this direction of the electron. Without applying that any electric field, it falls on the point here. So when you apply that electric field, that electron is deviated from its path. It is moving like this and it falls on this place. See, the electron is a negatively charged particle. That is why it is deflected through a positive electrode. So it's a positive plate is here. So the positive is attract the electron. So it is moving from here to here like this parabolic path, and it is falls on the screen here. So it's an actual path without applying the electric field. After applying the electric field, it is falls on this place. So it's a displacement is taken as y, right? That length of the electrode or that distance traveled by the electron is L. So y dash is the displacement of the particle. How much that electron is displaced, that is taken as y. The displacement of the particle on the screen is y. Okay. See that I already told you that when charge is placed on an electric field, it experiences a force of small e into capital E. So F equal to small e into capital E. So when the electron is accelerated, definitely it has the acceleration. So to find the acceleration, according to the Newton's second law, F is equal to ma. F equal to ma or a equal to F by m. So ae is the acceleration of electron. So 1 by m into F is here. So substitute that value in this equation. So ae equal to 1 by m. So instead of Fe, we are writing the value E into E. So E m by into capital E, where capital E is the electric field, small e is the charge of an electron, m is the mass of an electron. So acceleration is equal to small e by m into E. Now we are going to calculate the time period. What is the time period? Time period is the time taken to the electron moving inside the electrode. So time equal to, you know that formula for time equal to displacement by velocity. Here displacement is length of the plate, the metal plate, and V is the velocity. So T is equal to L by V. So we are not applying that any initial velocity to the electron. So that's why we are going to take U equal to 0. Acceleration equal to this value. So according to the Newton's equation of motion, you know that equation of motion, S equal to ut plus half at square. S equal to ut plus half at square, where S is the displacement. Here y dash is the displacement. So instead of S, we are writing that y dash. Y dash equal to ut plus half at square, right? Then y dash equal to ut plus half at, instead of at we can write ae t square. So here u equal to 0. When you put u equal to 0, this term becomes 0. So u equal to 0 means this term becomes 0. Then only this term is here. So ae value is substituted in this point. 1 by 2 small e capital E by f L by v whole square t square. You know the t value, t equal to L by v. So substituting in this equation L by v the whole square. Right. So squaring that value L square, it will become a v square. So v equal to, you know the value, v equal to E by b. The velocity of electron, v equal to E by b. So E by b, substituting that value, v equal to E by b, you will get y dash equal to 1 by 2 em L square B square by E. Right? So E by V means B square மேல போயிரும் E square இருக்கும் ஒரு E cancel ஆயிடுச்சு அதனாலதான் மேல E இல்ல கீழே E இருக்கு. So here the displacement on the screen is directly proportional to the deviation of the electron y dash or the proposed mark is here. So to convert the proposed mark to equal to we have to put C, that is constant. Y equal to C into y dash, right? So we know the value of y dash. We calculated the value y dash equal to 1 by 2 E by M L square B square by E. So substituting that value in this equation, see this is y dash. So y dash equal to this value substituted here, you will get y equal to C into C is a constant. So y dash value is here. So E by M is here in this equation, E by M is here. So keeping that E by M on that one side, the remaining things are taken to other side. You will get E by M equal to 2YE and that C L square B square is in denominator. Right? So you know all these values. These are all the values are constant. Substituting all these values, you will get 1.7 into 10 to the power 11 kilogram inverse part. Okay. So already we got the same value. So again you will get E by M equal to 1 by 1.7 into 10 to the power of 11 kilogram power minus 1. So this is the second method of getting the specific charge of electron. Now, the third one. So, deflection of a charge only due to a uniform magnetic field. So, magnetic field means now we are going to switch off the electric field. Electric and magnetic fields are there. Now we are going to use the magnetic field. So, we are going to switch off the electric field. Right? So, only magnetic field is applied. So, only magnetic field means that Fm equal to E into one minute. So here only magnetic field is applied, right? So electric field is switched off. So magnetic field, I already told you that when charge of an electron only placed in a magnetic field, it experiences the magnetic Lorentz force. That's called magnetic Lorentz force. That is Fm equal to EVB, right? So when magnetic Lorentz force is in the third lesson அதில் இருக்குமா நம்ம நடத்தும்போது பார்த்துக்கலாம். ஸோ அந்த இதை இங்கே அப்ளை பண்ணிட்டு இருக்கோம். ஆக்சுவலாக F is equal to VQB sin theta sin 90 equal to 1. ஸோ இந்த ஈக்குவேஷன் வந்துட்டு ஸோ அதை நடத்தும்போது நான் உங்களுக்கு ஓகே. ஸோ Fm equal to EVB is here. So when magnetic Lorentz force is acting on that any particle, that particle moving in a circular path. So when the particle is moving in a circular path, definitely it has the centripetal force. So that it is equal to mv square by r. So EVB equal to mv square by r square. So what we have to do is, so we can cancel that v value. V cancel each other. So remaining value is EB equal to m into v by r square. So m is brought here. E by m equal to v by vr. Or you can substitute that v equal to E by v. Already we calculated the velocity of electron v equal to E by v. So E divided by v square. So E v square r. So this is the another method of producing the specific charge of an electron. Suppose you apply all these values where E is the electric field, V is the magnetic field, and where R is the radius of the electron that is moving in a circular path, which has the radius. So radius r is here. Substituting all these values, again you will get the same value of E by m equal to 1.7 into 10 to the power of 11 kilogram power minus 1. Again you will get the same value. This is the fourth method of getting the E by M value.